Today we're going to be talking about function transformations. This is going to rely a little bit on what we've done before, adding a few more rules. The nice thing about this particular thing that we're talking about is that the rules stay very consistent all the way through. These work for linear functions, exponential functions, and piecewise functions. We're only going to talk about two specific kinds of function transformations today, the vertical shift and the horizontal shift. A vertical shift is moving up and down. For example, if you look over on the right, we have the function y equals x. I've already graphed it for us in the red. If I wanted to graph the function y equals x plus 2, our y-intercept should be 2. Our slope stays the same. We could graph that line. And then from here, I could say that compared to the parent function in red, the new function that we graphed is moved 2 units up. Similarly, I could do the same thing with, say, y equals x minus 3. Our y-intercept would be -3. We have the same slope, and it's going to look something like that. Compared to the parent function, y equals x, I would say that we would have shifted down 3 units. I'm going to write this as a more general rule over here. If we have a function, f of x, and we add k to it, we move up k units. Similarly, if we have f of x minus k, we move down k units. We'll try a few more of these in a minute. Now let's consider a horizontal shift. I'm going to pick a different linear parent function in this case. I'm going to use y is equal to 2x. For my parent function here, just simply put, it's going to be a little clearer if I use something with a slope that isn't 1. So let's go ahead and graph that in. It's going to look something like that. Now, if I wanted to write a function shifted to the right, it would look something like this. Y is equal to 2x plus 3. Scratch that. I meant to write x minus 3. Consider our original function. Let's go ahead and graph our new function. We can make a quick little f of x chart. We plug in our values. When x equals -2, f of x is going to be 2 times -2 minus 3, which is -10. Similarly, we can go through it. That'll be -8, -6, -4, -2, and 0. We can plot those points. And we'll end up with something that looks like this. Oops, didn't get that down far enough. Now notice here on the x-axis, we have this point here and this point right there. It has been shifted 3 units to the right. Now, I made that mistake earlier when I was writing it. I was thinking, since I wanted it to go through positive 3, that I needed to have a positive right here. However, you'll notice it's a negative. This is one of those kind of weird counterintuitive things. You have to move it in such a way so that the value you plug in for x will be where it crosses the x-axis or the x-intercept. And so it's kind of backwards from how you think it would be. Generically, it's going to look something like this. F of x plus k will move to the left k units, and f of x minus k will move to the right k units. It's a little counterintuitive. However, with a little bit of practice, I'm sure you can get kind of more used to it. We'll go ahead and do some practice problems now. We're going to graph g of x is equal to 2 to the x power. This is going to be an exponential. It's going to have a growth pattern to it. Let's go ahead and just fill out an f of x chart really quick, just to make sure that we understand where the points are going to go. So we get x, g of x. So 2 to the negative 2 would be 1 over 4. 2 to the negative 1 is 1/2. 2 to the 0 would be 1. 2 to the first is 2. And 2 to the second is 4. We can plot said points and create our graph. One-fourth is right about there. 1/4 is right about there. 1, 2, and 4. Now I'm going to go ahead and graph our transformations for some other things on the same coordinate system so you can see it a little clearer. So if we wanted to graph something like g of x is equal to 2 to the x plus 3, I'm looking at that and I'm thinking to myself, the transformation is going to be up 3 units. So I would expect it to look something kind of like this. That's just me kind of doing a rough sketch. We can do a much more accurate job of that here. I'm going to go ahead and make our xg of x chart like we did the first time. You can use whatever numbers you want for x, but I'm picking the ones closest to 0 because I know this is an exponential graph, and therefore they'll be the most manageable. So if g of x is 2 to the x plus 3, this one would be 3 plus 1/4, 3 plus 1/2, 3 plus 1, 3 plus 2, and 3 plus 4. I'm just taking the values that we had there, and I'm literally just adding 3 to them. So that'll be 3 1/4, 3 1/2, 4, 5, and 7. We can connect the dots, and we see that it did indeed move up 3 units. I think I got that one last point a little low, so I'm going to just go fix that right now. Erase out my other stuff. Just I want it to be a little bit more accurate. Similarly, we can do the exact same thing for 2 to the x plus x minus 5. I'm going to pick a different color, We'll go purple. That's my favorite color to use on this. Now I want to point out one huge detail here that's very, very important. You'll notice that the plus 3 is on the outside of the exponent, whereas here, our minus 5 is included with the exponent. So make sure that you notice here that the same holds true. These two outside the exponent, and these two inside with the x. That's how you know the difference between an up and down move and a left and right move. So let's go ahead, get back to what we were doing. We'll make our handy dandy little chart. So now we get 2, negative 2 minus 5, that's negative 7. Which I believe is 1 over 128. That's a very, very small number. Similarly, we'll end up with so this is so far into the asymptote that these points end up very, very, very close to the line. If we were to keep going, we would eventually run into it looking something like this. Meaning it's been shifted to the left 5 units. All right. We'll go ahead and just do our last one. G of x is equal to 2 to the x plus 4. We'll do this one in green, I think, so we don't get it confused with the other blue one. I'm expecting this to go to the right 4 units as the x is included with the exponent here, and that's a positive exponent. But we'll just double check that really quick and see what we get. We get x in g of x, negative 2, negative 1, 0, 1, and 2. Same thing as we've done before. So we get 2, negative 2 plus 4, which is 4. Negative 2 to the negative 1 plus 4 is 8. 2 to the 4th is 16. 2 to the 5th is 32. And 2 to the 6th is 64. So now when we start plotting these points, we will see that they are significantly higher than all of the other ones that we've had so far, to the point where we're really, really going up there. I'll just plot that last one and just kind of connect the dots. It's going to come down like so and level out that way. And as you can see, it did indeed move in the appropriate direction. Let me know if you have additional questions.